Hey guys, Mr. Milton here. Today we're going to talk about the triangle angle sum theorem. At the end of this video, you should be able to use the two theorems to find missing angle measures in a triangle, and you should be able to classify triangles by angles and sides. Okay. First theorem, the triangle angle sum theorem, says that that the measures of the angles in any triangle add up to 180 degrees. Okay, so the fact that every triangle will add up to 180 degrees when we add their angles together. So we'll use that a lot. In this problem, we'll use it to find the measure of angle 1. We're given two angles, 148, and then the measure of angle 1, I'll just call that x, equals 180. We can find x by subtracting 148 from both sides, and once we do that, we'll get the answer to be 32. So the measure of angle 1 is 32 degrees. Knowing that the triangle added up to 180 really helps us out. Alright, second problem here, we're given x, y, and z, and we need to find their measures. You'll notice in this picture we're given a lot of different triangles, okay, and each of them has an angle sum of 180. Okay, so even though there's x, y, and z, there's no need to find those in alphabetical order. Find what you can see. As I look quickly, I'm looking at this triangle here that's drawn for us because this is angle y. I see I have two angles here, 21 and 32. I know that all three of these add up to 180, and so I'll say that's 53. So y plus 53 has to equal 180. Subtract 53 from both sides, and we'll get that y must be 127. 127. Okay? Alright, now, we can use that information a bunch of different ways, but I'm going to stick with the triangle angle sum theorem here. And so if we notice this big triangle, and I'm going to just redraw it here so we can see it, the angles written out more clearly. In the big triangle here, we have this angle to be 32, this angle to be 57, and this angle we don't know at all, but we know that it's like z and 21, so z plus 21. Okay, do you see that? These two angles together here for that angle. And so those add up to 180 as well. So we'll add the numbers that we do have together. It's 89 plus 21, which is 110. So z plus 110 will equal 180. And so then we subtract 110 from both sides, and we'll find that z is 70. So a couple different ways now to find x. I'm going to stick with the triangle angle sum theorem, and say, hey, these three angles have to add up to 180. 57 plus 70 will give us 127. So 127 plus x will give us 180. Subtract 127 from both sides, and we'll find that x is 53. Okay. Should make us feel better that these two angles together make up a straight line, and so they should add up to 180 degrees, and when we add those together, they do add up to 180 degrees. So using all the tools in our toolbox to solve and verify our answers. Okay, so that's the triangle angle sum theorem that says that all triangles add up to 180. Now we're looking at the triangle exterior angle theorem. The triangle exterior angle theorem says the measure of each exterior angle of a triangle is the sum of the measure of its two remote interior angles. Okay, and the way that I was taught remote interior angles is the one that stuck with me, and so I'm going to do this. If this is the exterior angle, angle 4 is the exterior angle, okay? And if you imagine the angles inside the triangle as televisions, okay, I'll draw my televisions with antennas, okay? Okay. Angle 4 is right next to angle 3, okay? It would just change channel with his hand. to change the channel for 1 and 2, would need to use a remote controller. Those are the remote interior angles. Okay, remote can mean far away. So if you want to remember it that way, then go ahead. If not, then you just have to think about it and remember it. Okay, so now we're going to have a proof to make sure that we know that this has to be true. And so let's look at it. So we're going to prove that measure of angle 1 plus measure of angle 2 equals the measure of angle 4. And I'm going to do this in a 2-column proof. One column is going to be my statements. The other is going to be my reasons. Okay, in my first statement, I'm going to say that angle 1 plus angle 2 plus angle 3 equals 180. Let's do that. Okay, and I know that because that's the triangle angle sum theorem. Triangle angle sum theorem. Okay, that we just talked about, that all three angles have to add up to 180 all the time. Okay, now I'm going to say that the measure of angle 4 plus angle 3 equals 180. Okay, notice that these two angles make up a straight angle. That's the angle addition postulate. And so now I can say that I'm going to just substitute, because angle 4 plus angle 3 is 180 and angle 1 plus angle 2 plus angle 3 is 180. I'm just going to substitute and say angle 1 plus angle 2 plus angle 3 equals angle 4 plus angle 3. Again, that's just me substituting. And then I can say, finally, angle 1 plus angle 2 equals angle 4. And I'm going to do that by subtracting angle 3 from both sides. So that's subtraction. Alright, and so now I've proved it. Notice again that my last step in the proof is not prove. I'm saying why I got here, not why I'm trying to get here. I got here by subtracting. Alright, so that's the proof, just in case you need to know why it works. It does work. And so now we can continue to use it and feel better about understanding what we're doing. Alright, so now let's use that information in order to solve for x. Here, we're given this angle out here is 100 degrees. I'm going to write it. I don't know why, because I just started writing it. And now they want us to find the measure of angle CAB. Important here. That's here. ACB. That's here. And ABC. And so we will set this up and say this is the exterior angle. Its two remote interior angles are here. So I can set up my equation and say the exterior angle, 100, equals the sum of its two remote interior angles. So 6x plus 5, which is one of them, plus 9x minus 10, the other. Combine my like terms, I get 15x minus 5 equals 100. I'll add 5 to both sides. So 15x equals 105. I'll divide by 15, which gives me 6. No, let's see. 105 divided by 15. 7. There we go. Glad I used a calculator. Alright, so then I find that x is 7, because I divided both sides by 15. So now that I find x is 7, I can fill in my values here. 6 times 7 is 42, plus 5, 47. 9 times 7, which is 56, minus 10. 46. That doesn't seem right. 15 minus 5x plus 5. Plug 7 in. 7 times 6 is 42, plus 5 is 47. 63. There we go. That's 63 minus 10, which is 53. Here we go. There we go. Alright, so CAB will be 47 degrees. ACB will be 53 degrees. And then ABC, I really could have found this from the beginning because this is 100 degrees. Then this right with it has to be 80. Or I could do the triangle angle sum thing and find that 47 plus 53, 180 minus that. Alright, so there we have it. Alright, so now let's add some vocab to this. So that math should be hopefully pretty simple there. Math isn't bad, it's remembering the theorems and applying them. But we're going to add some vocabulary here and learn how to classify triangles. And we can classify triangles by sides and by angles. Okay? So here are the different types of classifications. When a triangle has all sides congruent, we call it an equilateral. Equilateral means equal sides. Okay, typically you might see something like that. Okay, when exactly two sides are congruent, we call that an isosceles. Okay, so something like that. Only two sides are congruent. Where in the equilateral triangle, all three were. This is congruent. And then in a triangle where no sides are the same, we call those scalene triangles. I don't know, you might see it drawn something like this, like 1, 2, 1, 2, 3. Notice that they all have different markings, but they're not the same. Okay, when we classify triangles by angles, we can call them, if they're all the angles are congruent, we call them equiangular. Equiangular. Okay, when all the angles are acute, we call them acute triangles. When one right angle, we call it a right triangle. Notice that if we have one right angle, the other two angles are going to be acute. So we're just looking for, in acute triangles, all the angles have to be acute. But in right triangles and in obtuse triangles, we just need one angle that is that way. Okay. So the acute triangle, all angles have to be acute. In the other triangles, we're looking for the biggest one to identify what kind of triangle it is. Okay. Quick thing here. Equilateral and equiangular triangles. If a triangle is equilateral, it'll be equiangular as well, always. Okay? And we typically call that a regular triangle. Okay? But we'll look at that more later. Okay, so now it's asking us for to classify these triangles, triangle MPR, and we're going to classify. We can classify these based off of angles, and we can classify them based off of sides as well. So let's find these angles, and then I'll leave it to you to classify them. So here we have that this is giving us that this is a 90-degree angle. So since this is 73, then we can figure out this other NMP would be 17. Okay, again, this is a triangle here, so we're going to use the fact that triangles add up to 180 to find out MPN, and that is 79, 101. Okay, since this is 101, then I know that this will be 79, 73, 79, that's 152, so that makes this 28. Alright, so those are all the angles. I classify these triangles by their angles. Okay, so it doesn't say classify each triangle by its angles, but it doesn't give us any information about its side lengths. So we can only classify these by its angles. Classify these by angles and bring those into class tomorrow. Done. Thank you. See ya.